got what you want to do. Take this and multiply by x minus 1 over x minus 1. Got it right. Okay? Again, I'm doing this problem backwards. All right? I'm doing this problem backwards right now. We'll move forwards in just a second. I want you to realize where a lot of the problems are coming from in your textbook. So, Harry is absolutely correct. When you multiply a function by linear term over linear term, right? All that does is make a hole. That's all it does. Okay? Why? Because I now know I cannot put 1 into this because I'll be divided by 0. That's not allowed. So 1 cannot go in here now. So there's a hole. But at the same time, since x minus 1 is also a factor in the numerator, it leaves every other value around the hole unchanged. Right? Make sense? When I put in the number 0 right now, when I put 0 into this thing, what happens? Well, this is the number 1. So I have 1 times whatever 0 plus 1 is, which is 1. It lands in the right spot. When I pick negative 1 to put in here, this is 1. So therefore, 1 times negative 1 plus 1, well, that's 0. It lands on the x-axis. Okay? This is the quintessential way to remove pieces of a graph. Okay?
Would you leave it like that?
What's that?
Would you leave it like that?
No, we're going to check what Carrie said. We're going to write it like this, because this is the way you will normally see it in a problem. F of x is x squared minus 1 over x minus 1. There's our function. And you would not have realized it was a line with a hole in it if you had just come across x squared minus 1 over x minus 1 in your textbook. Probably not realized.
So you just take the difference of 2 squared at the top, right?
Yeah. But this is the way the problem will start. The problem will look like this. Forget you know anything about what we just said. Forget you know anything about what we just said at all. Okay? The problem is going to look like this. I want to find the limit of x squared minus 1 over x minus 1 as x heads towards 1. Okay? That's what I want to do. And we're going to do a little bit of algebraic chicanery to make this limit work out. Okay? But given that you see the picture we started with, you know what the answer is.
Wait, are we starting?
This is problem. Problem textbook. Text problem 2.3 number usual. Okay? Whatever. This is the way the problem looks in textbook. Okay? I want to know the limit of x squared minus 1 over x minus 1 as x goes towards 1. What do you notice about the number they picked? They picked a number such that the denominator is heading towards
0.
0. Right? Denominator heading towards 0, not 6. That in itself should alert you to one or two things. Either the answer is undefined, D and E, right? Or the other case is, if the top is also heading towards 0, there is hope. Perhaps the limit actually does exist. Okay? This is the most common occurrence of every problem in the textbook, in limits. Bottom heading towards 0, and you need to think about what the top is heading towards. If it is heading towards, if this heads towards non-zero, the answer is D and E automatically, right? If you have a non-zero, heading towards non-zero above and heading towards 0 below, you're really heading towards infinity, which is D and E, right? If this is heading towards 5, this is heading towards 0. As the bottom gets ridiculously small towards 0, the fraction is exploding. The fraction is becoming super colossal, right? You guys with me on that? Right? As fraction denominators get small, meaning towards 0. I don't mean negative small, right? I don't mean like negative billion. I'm saying as it gets close to 0, a fraction blows up, right? You guys with me on that?
Mm-hmm.
I feel like some of you are questioning it. It's okay? Hand pushers help?
So in other words, if you have 0, the denominator is 0, then the numerator is 5. Is 5.
Yeah. Let's say this heads towards 5. Okay. So as the top, let's just pretend it's fixed at 5 for a moment. It's practically 5. So then if the bottom is close to 0, well, what's 5 over 0.1? What's 5 over 0.01? Getting close to 0, what's 5 over 0.001? These numbers are getting very large, right? This is like 50.
Correct.
This is like 500. 5,000. It's going to keep getting larger without bound. So if the bottom is heading towards 0 and the top is heading towards non-zero, it's game over D and E. right?
Yeah.
But they have picked a case where the bottom is heading towards 0, and the top is heading towards 0 as well. So if that's the case, 0 also, then hope. There's hope. Maybe a limit will actually exist.
Okay, so you said if the bottom is heading towards 0,
Yeah.
it's D and E.
If the top is also heading towards non-zero.
Both of them.
So they both have to be heading towards. Wait.
If the top is heading towards non-zero, if the top is towards 5, 8, negative 100,
Uh-huh.
it's non-zero, and the bottom is heading towards 0, D and E.
Okay.
Because it's heading towards an infinity, one or the other.
Okay.
All right? If the bottom is heading towards 0, first focus is below. If the bottom is heading towards 0, and then you examine the top and it's also heading towards 0, hope exists.
Okay.
Okay.
All right? There could be a finite value the thing is heading towards. This is our case.
All right.
What is the finite value our limit is heading towards? 2. As x, right, 2. Right? This stupid looking thing is heading towards 2. Right? Now, you know it right now from the geometry. Right? I'm showing you it's a line with a hole. So as x heads towards 1, the curve is heading towards the hole. What is the height of the hole? 2. Problem's over, the answer is 2. But you're not going to have graphs in front, you're not going to know the pictures all the time, right? You don't want to graph all these things. So we introduce an algebraic game. Oh, I'm so, all right, so let's see. So we have hope this time. What is the hope? We're going to work this backwards. Right? We're going to factor it. Factor and cancel. Factor and cancel is the main technique for evaluating the limits that are in your textbook. Factor and cancel. Right? Factor and cancel. No, that's it. This should be the same as the limit of x minus 1. There's our difference of squares. Similar you were talking about. 1. Right? So now the idea is that whenever you factor and cancel, it does not affect the limit. That's the thing. Why does it not affect the limit? Because remember that x is heading towards 1, it will never become 1. Right? Right? You're heading towards 1, and that x value is not even allowed to reach that quantity. So therefore, since x will never be 1, then this factor and this factor here are unaffected by the limit. Right? 1 is the only problem here. 1 down here makes this 0. But that's never going to happen. X will never become 1 in this limit. Right? X is always just around 1. So therefore, for every number just around 1 that you were to substitute in here, it's going to be like this was just not even there. Right? So now you have the limit of x plus 1 as x goes towards 1. So here, there are some rules that I'll tell you in a second, but yeah, go ahead.
So why did we factor and cancel?
Because we didn't know what was happening until we factor and cancel. Because you're not going to have this before you.
Oh, it's
You will not have the geometry before you. I just want to show you what this is saying geometrically so you understand why the limit even is what it is. Because along with the hole. So it's heading